So this is lesson 9.6b, and we are ready for example 5 in intermediate algebra. And we're just doing different situations that might come up, and they all have to do with squaring the radical. Okay, the difference is, look what we've got here. On the left, we have everything under one radical. Under here, we don't. But we're trying to get rid of the radical. This one over here on the left is by itself, so that means that's good. We're going to get rid of that one first because it's by itself. And we square both sides. So this becomes x minus 3. This here becomes, and let's do it in blue, kind of over to the side. Okay? We have to do the FOIL method. So that gives me this times this, which is the square root of x squared, or whenever you multiply two radicals together and everything underneath is the same, you just take the radical off. So that's f. O for FOIL would be the outsides, minus 3 square root of x, because it would be this one and this one. And then we have minus insides. And then we have last, plus 9. And then we can add these up. Okay, and that's what goes right here. Make myself more room here, get this out of the way so get the confusion gone. Alright, now what happened is I still have a radical here. I've got to get rid of that. So I've got to get rid of everything on the right hand side, so I just have the square root of x. So I'm going to subtract x from here, subtract x from here. So that gets rid of that one, and that also gets rid of this one. X minus x is 0. And let's just, rather than scribble if I can. Okay, then we're going to subtract 9 from both sides. And that gives me negative 12 equals negative 6 square root of x. Okay, so see, I'm slowly but surely getting rid of stuff. Then I divide both sides by negative 6. And I get a positive 2 equals square root of x. Then I square both sides. I get 4 equals x. Okay, that all looks well and good, but I'm not home free yet, because now I have to take my 4 that I got for x and plug it in. Alright, so I got square root of 4 minus 3 equals the square root of 4. That's what my x is. So square root of 1 equals 2 minus 3. Square root of 1 is 1 equals negative 1. That does not work. So my answer of 4 is not an answer. There's no solution then if I get an answer like that. If it doesn't work when I check, you just say, sorry, there's no answer. Alright, let's look at example 6. We have x plus 1, and then we're going to make that equal to 1 minus square root of 2x. Okay, again, same thing. We've got an isolated radical on this side, so we're going to square both sides. I'm just going to rewrite it. This becomes x plus 1 equals, do the FOIL method again. So we have to multiply this by itself, like that. So the first one's 1 times 1 is 1. The outside, this one and this one, is negative square root of 2x, and then inside, and then this one and this one, my two last ones. What am I doing? I'm squaring them, right? And I get a plus sign here because I have a negative times a negative. Alright, so these are squared, so the squared here takes away the radical sign, so I wonder if I can, I don't think I can erase it, so let's just scribble it. That goes away, and that goes away. Alright, so let's combine what we have. 1 minus 2 square root of 2x. Okay, get rid of those. plus 2x. Move everything to the left. So we're going to subtract 2x. So that gives negative 1x. We're going to subtract 1 here, subtract 1 here. Gives me negative x. Instead of negative 1x, we'll just make it negative x. Those go away. Those go away. Okay, so let's keep going here. I'm going to move this over here because I'm going to need that later. Alright, then we're going to divide by negative 2. Divide by negative 2, and that gives me x over 2 equals the square root of 2x. Now, I'm going to have to square both sides because I'm trying to get rid of this radical. So then this becomes just 2x, and this becomes x squared over 4. Okay, so what do we do with what I have there in red? Well, this is 2x over 1, and I have an equal sign. I have two fractions, so I can cross multiply. Cross multiply. So I have x squared. I'm going to subtract this from both sides, and I don't have anything left over there. Now I can factor out an x. So you're doing a whole lot of algebra that you've learned in the past and very possibly have forgotten, since you might not have done it for a while. And that gives us two possible answers. What is multiplied together give me 0? Well, this x has to be a 0. And then no matter what is in here, 0 times whatever is in the parentheses is going to give me 0. Or x equals what makes this 0? 8. 8 minus 8 makes it 0. Then I multiply that 0 times whatever this is, which it doesn't matter. So those are my two answers. Now I have to take both of those answers and put into the original one to see what I get. And when I put those in, I find out that 8 works, or I mean 8 does not work, but 0 does work. Okay, so then you just write for an answer. X is 0. You throw out the 8. Alright, let's look at example number 7. And we'll do that one. And I think there's one more example, and then we'll be done. Example 7 is x plus 1, and that equals square root of x plus 2, and then that's minus 1. Okay, we're off to it again. Our radical on the left is isolated, so we square both sides. And this is the easy side. And then we have to take this second one here and do the FOIL method. Yuck, FOIL method with that. But let's just take it one piece at a time. So my f is going to be this times this. Okay. Square root of x plus 2, and we're squaring it, which means it's just x plus 2, right? And we'll put it in parentheses here. My o is going to be my outside, this times that. And that negative 1 doesn't do anything, so it's just minus square root of x plus 2, because it's really a minus 1 times this, minus 1 times this, and the minus is there, but we can just throw out the 1. Alright, inside is going to be these two multiplied, which again is the same thing, minus. And then lastly, negative 1 times negative 1 is positive 1. So we have x plus 2 minus, right, if that's a 1 there, and that's a 1 there, it would be minus 2 square root of x plus 2. So remember, when you're adding radicals, you add the numbers in front of the radicals, and the radical, everything in there just stays the same. We don't do anything with it. So we just added the 1 and the 1 and got our 2. Then it's plus 1. Then I can combine that with that and get x plus 3 minus 2 square root of x plus 2. that bit of information right there is what's going to go right there. That is the FOILed, this part here that we multiplied. That's all we did. So we have x plus 3 minus 2 square root of that. Alright, so let's see if I can erase some things here. Probably not. Alright, so what we have here then is this whole thing that we had up here simplified to this. We got rid of this radical, but when we did that, it made all of this turn into this. So this is where we're at. Now we need to get our radical over here, the square root of x plus 2 by itself. So we have to get rid of all this. So we're going to move it all over there. So I'm going to get rid of all of this and just have this equation right there. Okay, there it is. Alright, let's go ahead and move all of this over, one step at a time. Subtract x from both sides. That gets rid of my x. Really, x minus x got rid of that one there and that one. Now we're going to subtract 3 from both sides. 1 minus 3 is negative 2. Divide by negative 2. Divide by negative 2, and that gives me 1 equals, those cancel. Okay, that's isolated. It's all by itself, so it makes it real easy to square both sides. I get 1 equals x plus 2, and subtract 2, and x equals negative 1. That's what I get for an answer there. Alright, now I put it back into this problem, and it works, so we're okay there. Alright, a couple more examples here. Example number 8. Alright, do you notice something different here? We have a cube right here, a 3. So we can't square both sides to get rid of this. What we end up doing is abracadabra, we cube both sides. And that gets rid of my radical. But my 3 doesn't turn into a 9, it turns into a 27. 3 times 3 is 9 times 3 is 27. Subtract 5, and I get 4x equals 22. X equals 22 over 4, which reduces to 11 over 2. And I get that there. Okay. So because, and this is important, because we have an odd power here, you don't have to check extraneous roots. You don't have to do the checking. So if you have a cubed root or a 5th root or a 7th root, you don't have to put this back in to check and see if it works. It's only if it's square roots or 4th roots or 6th roots. Alright, so that's it for lesson 9.6. I will not have you do the graphing, so we won't worry about that. And that's it.